Hey guys, welcome back. So, today we're going to learn about search and sort algorithms in this lesson. We have two types of algorithms, which is the linear search and the bubble sort. You will use the linear search when you're searching for a value or if you want to find out if a value appeared more than once. And a bubble sort is used to sort data in a specific order, either if you're gonna arrange them in an ascending order or a descending order. Okay, so first of all, I'm gonna give you guys a bit of background knowledge on arrays. This lesson won't cover it in detail. We're gonna do that in the next lesson, but I'm just gonna give you a little summary of how arrays work. Okay, so an array can be of two types. It can either be a 1D array or it can be a 2D array. A 1D array is very simple. It's just a line and it has different compartments in a straight line horizontal manner. But a 2D one is more of a boxed shape table. It's like the Excel you have, the Microsoft Excel, kind of like that. It has rows and columns. The horizontal lines that you can see are known as rows, and the one that goes straight down are columns. Now, I like to do this one trick, which is known as the XY method, and I take rows as X because they are horizontal, and I take the columns as Y because they're vertical, just like in a graph. So when you want to call an object, what you do is you first write your array name. Let's say it's array name, okay? Array underscore name. And then you open square brackets and you write the position in which your item or value is stored. So if you want to give positions to your values, you start from either 0, 1, 2, 3, 4. Or you can start with 1. 1, 2, 3, 4, 5. It really depends on the algorithm you're using. For pseudocode, you can use either. So I'm going to start off with 1. Let's say in my first column, I have a star. In the second one, I have a circle. Third, I have a square, a triangle, and a smiley face. Now, if I want to call this circle, I'll put 2. If I want to call, let's say, the smiley face, I'd put a 5. Just like that, you can call any item you want. In a 2D array, you need to be more specific because there are a larger number of values or items. So there are 2 spaces you need to fill out. Let's say, let's put some items in. A star, a heart, square, circle, triangle, question mark, exclamation mark, A, B, C, a cloud, a sad face. Okay. Now let's number them. 1, 2, 3, 4. 1, 2, 3. Okay. Let's say I want to call a question mark. I'll first write the array name, which is the array name for now. And we're given a square bracket and there are 2 spaces we need to fill out. For the question mark, as I said before, X, comma, Y. Just like in mathematics, you'll use the same concept in computer science. So for the question mark, you see the x-axis. The question mark is in number 2, you'd put 2. And then in the y-axis, it is also in number 2, so you'll put 2. So if you call array underscore name, square bracket, 2, comma 2, close the square bracket, and then you'll get the value of the question mark. Now, the values are not always shapes. You can put literally anything in the world. You could put names, country names, mobile number, your favorite color, anything you want, you can put in the array and you can call them. And we're going to use this concept to use our linear search and bubble sort. Okay, so now let's talk about how linear search actually works. So here I've drawn a little table. It's a 1-day array, and I've numbered them 1 to 10. Now we're gonna find how many hearts are there in this array, and we're gonna put them in the tally. So first of all, we're gonna ask ourselves: is the position 1 equal to a heart? It's actually a circle, so no. We're gonna move on to the next one. Is position 2 equal to a heart? Yes, it is. So we're gonna put 1 point in our tally. Next, move on. And position 3, is it a heart? No, it is not. It is circle, so no tally. Then 4, is it a heart? No. Is 5 a heart? Yes. 1 more tally point. Is 6 a heart? No. Is 7 a heart? No. Is 8 a heart? No. Is 9 a heart? Yes. 1 more tally point. Is 10 a heart? No. So now we know our answer. There are 3 hearts in the entire array. And this is how we generally use the linear search. Now let's go on to actual code and see how it works. You can see over here, I've made a little array and put some values in. So let's number them. Position 0, 1, 2, 3, and 4. There are 4 positions. This is just an imaginary array, just for the sake of understanding how this array works. Okay, so let's read. For array index is equal to 0 to length array minus 1. Now, this is basically a for loop, and you're gonna go from 0 to length of array minus 1. We don't know what is the actual length or how many items there are actually in the array, but for the sake of understanding, I have made this array. And over here, you can say that there is 1, 2, 3, 4, 5 items in my array. So it should be 5. 0 to 5. And you can see there's a minus 1. So minus 1, which what does it give us? It gives us 4. So basically they're saying we're going to go from 0 to 4. We're going to loop it 0 to 4 times. This code, this entire code, we're going to loop it. Now, why is it 4 even though there are 5 items? This is because we started our number or loop from the number 0. So 0 is also considered a loop, right? So now just see 0, 1, 2, 3, 4. You can see that there are 5 dashes or 5 lines, right? So yeah, but using that logic, our code is gonna run 5 times. Okay, let me erase all of these. Alright, so it's gonna go from 0 to length array minus 1. So our first array index is 0. Let's put that there. Okay, next, if data array, which is array index, equal to search value, then now what is data array index? I'm going to show you how it is represented. It's basically data array is the array name, and you have the square brackets. And what was array index? It was 0, so we're going to put 0 in the square brackets, right? If that is equal to the search value. And let's put a search value, let's say 5. Okay, that is our search value. So how are we gonna interpret this line of code? Data array square bracket 0 is 2. As you can see from the array, you're gonna put a 2 here. Is equal to search value, which is 5. Is this true or false? It is false because 2 is not equal to 5. So if it is not, then we're just gonna ignore all of the rest of the code and move on to next array index, and the array index is going to increment to the next value. So 0 is going to become 1. Okay. So now again, you ask yourself, is data array 1 equal to search value? What is 1 from our table? From our table, 1 is 7. Also, is 7 equal to 5? No. So we're going to ignore the rest of the code and go to next array index. Again, our array index value is going to increment to 2. So is now array index 2 equal to the search value? What is 2? 2, it is 5, right? So is 5 equal to 5? Yes, there is a match. So we found it. So we're gonna see what the code tells us to do. It tells us to output found at and array index. So how it's gonna be represented is you're gonna get an output of found at, and our array index value is 2. Found at 2. This is gonna show up on your screen on the user's end. And then it goes on again. Next array index, it checks the third position. It's not equal to 5. And then the next position, the fourth position, it is also not equal to 5. And our code ends once all of the positions are checked. But you do observe a problem in this code, because even after you find your value that you're looking for, the code loops again and again until all of the values are checked. And that's just a big waste of time, because if you already found it, there's no need to do all the searching. So to improve the code, we have another code and we're going to look at it next. Here, so let's read it together, and I'll put my search value as 2 this time. Okay, so found is false. Let's just put there, our found is false. And array index is 0. Okay, array index is 0. So while found is equal to false, and our found is equal to false, so we can continue with the code. If data array index is equal to search value, then okay, so this is the same code line we have done before. It's just data array and then the array index, which is 0 right now, is equal to our search value, which is 5 right now. If it is, then you need to output at and array index. But let's pretend that it is not equal to the search value. So we'll just ignore all of these code and we're going to go to the else part. Else, array index is array index plus 1. So it basically increments again by 1. So now 0 plus 1 is going to give you 1. And then end if, and while it has to go back to the beginning of the code, and you check the criteria again. While found is equal to false, found is still equal to false, yeah, so you can continue with the code. So if data array index is equal to search value, so data array index, now it's gonna be 1 is equal to 5, then output found at and array index. Now let's pretend that yes, we have found our search value. That array index was 5 is equal to 5. If it is true, then you need to output found at and array index. So this is what is going to appear to the user. Found at array index, which is 1. And then found becomes true. Now this changes to true. The variable found, it changes to true. And then it just skips this else part and it goes back to the beginning. So while found is equal to false. Now check the criteria. Is found equal to false? No, it is not. Found is equal to true. So this code is not going to execute and it's just going to skip and go to the next part, or the code is just going to end. So now let's talk about how the bubble sort program works. So you can see over here that I've just drawn out a little array with only two values so that it's simple and easy to understand. And we have these 5 essential variables over here: index, index plus 1, array index plus 1, and temp. These are very important when you're doing bubble sort. So let's say we're gonna arrange them in an ascending order. Okay. So first thing is the value that is gonna be stored in the index variable. So we usually use a for loop. So the first value that is gonna be stored in index is 1. And index plus 1 is nothing but the value that is stored in index plus 1. So 1 plus 1 is 2. Now we have this very important statement: array index is more than array index plus 1. Array is nothing but the name of the array that you have. I'm just putting array over here. And array index. So just like how we did before, array index, which is array 1, and the value stored over there is 5. It is more than array index plus 1, which is the value stored in the position 2, which is 3. So 5 is more than 3. And also let's put the values in our variable. Array index, it is 5, and array index plus 1 is 3. Now, if it is true, if this statement is true, 5 is more than 3, we do a bunch of stuff, which is a bit complicated, but I'll make it really simple. What we do is the value that is stored in array index, we will transfer it to the variable temp. So it was 5, and 5 is going to be stored in temp. Then the value that is stored in array index plus 1, it is going to be stored in array index. So 3 is going to be stored in array index. Then the value stored in temp is going to be transferred to array index plus 1. So 5 is going to be stored here. Now you notice that earlier 5 was in array index and 3 was in array index plus 1, and now it's swapped. It's like flipped, you know? And that is exactly what is going to happen to our array also. 3 is going to come first and then 5. Now notice how the values are in ascending order. 3 is the smaller number, so it's first, and then 5 is the bigger number, so it's the back. So what this code essentially does is that it pushes away the bigger number towards the end of the array. And if you wanted to do it in a descending order, all you need to do is just flip the sign. So the greater than sign becomes a less than sign, and your values would be arranged in an ascending order. Next, let's look at a code version of the program. Okay, so for index 0 to length array minus 2. Now this is a very important part. You notice how I put minus 2 instead of minus 1 when the number is 0. This is a very important concept. Let's say we have an array, and let's number them 1, 2, 3, 4. Now the last position in the array, which is 4, it cannot be compared with a non-existent position. Like, let's say 4 was the index. So the index plus 1 would be 4 plus 1, which is 5, but 5 does not exist. So you can't really compare it with anything. That's why we always subtract minus 2. Or if you did start it with 1 to length array, then you would have minus 1. You would need to put minus 1. So yeah, depending on what you start with, you need to subtract minus 1 or minus 2. And the rest is the same. If array index is more than array index plus 1, then temp stores array index stores array index plus 1, and array index plus 1 stores temp. And if next index. You can also have a while loop version of this code if you want to stop running the code if the array has been arranged already in ascending order. So changes is true. Well, changes equal to true, you have to do for index 0 to length array minus 2, changes becomes false. If the array index is more than array index plus 1, then temp becomes array index becomes array index plus 1, and array index plus 1 becomes temp, and the changes becomes to true because there was a change, that there was a swapping that happened. And then end if, next index, and while.